Hi guys, welcome back to my channel Pirai Academy. In the series of Zoho interview question, now we are going to see about a question called index of an extra element. Okay, you have given two sorted arrays, array 1 and array 2 of distinct elements. The first array has one element extra added in between. Return the index of the extra element. Note, zero-based indexing is followed. Fine. Now, if this is the array 1 and this is the array 2, then what is the extra element that is added in the array 1? It is 9. Okay, so we want to return the index. So 0, 1, 2, 3, 4. So 4 is the required answer. Fine. How to do this in an efficient way? First of all, we can see with the brute force approach, then we can step by step go to the better and then optimized approach, because that will be giving you an intuition, right? Okay, so what is the basic brute force approach that comes into our mind? It is like just traverse this array 1. Okay, now it is what 2. Now I want to traverse this array 2 and check whether this 2 is present or not. Just a linear search, that's it. Just traverse one by one element. Okay, so whether 2 is present, yes. Whether 4 is present, yes. Whether 6 is present, yes. Whether 8, yes. Whether 9, no. So we want to return this index. So the answer will be 4. Okay, what's the time complexity? It will be O of n square will be my time complexity. And what is space complexity? It will be O of 1. Fine. So this is not a pretty much optimized solution, right? So this is a brute force basic approach. Okay, how to still get into a optimized, still a better approach? So instead of searching this by using a linear search, okay, it is a sorted array, right? It is sorted in nature. So if it is sorted, then I can use a binary search insert, right? So that a time complexity will be slightly reducing. So if I use a binary search approach, so it is a approach number 2, it is binary search. So if I use binary search approach, then the time complexity will be reduced to O of n log n and the space complexity will be O of 1. So it is pretty much optimized than this, right? Okay, fine. So if you want to know about this binary search, just go and see my YouTube video. I will give the link in my description. Just go and watch it. That it will be more clear. Fine. Now let us go to the next approach. So it is n log n. Still we can just reduce this, right? If I want to reduce this still further, then it will be O of n, right? So whether I can use something in which we can exactly find the unique elements. Okay, so there is an operator called XOR. So in this XOR, what is speciality of this XOR? If we just do a XOR operation on a same number, then the result will be 0. And if we do a XOR on some number with 0, then the result will be that some number. So 8 XOR 0, which will be 8, and 8 XOR 8 will be 0. Fine. So that same logic we are going to use here also. How? Just to take just a variable s is equal to 0 initially. Now I am going to keep on traverse. Okay, first it will be 2. So I will be taking the 0 XOR 2, then XOR this 4, then XOR 6, then XOR 8, then XOR 9, then XOR 10, then XOR 12. Then again I will go to this array. Go to this array and take every element as a XOR. So 2, then 4, then 6, then 8, then 10, then 12. Okay, now listen this carefully. The same numbers, when we are doing a XOR, it will become 0. So this 2 and this 2 leads to 0. This 4 and this 4 leads to 0. This 6 and this 6 leads to 0. This 8 and this 8 leads to 0. And this 10 and this 10 leads to 0. This 12 and this 12 leads to 0. So what is the remaining? It is 9. So we just go and search in which index this 9 is present in this A. Okay, this array 1. Now I'm just again keep on traversing and check whether where it is 9. So here it is 9. So I will return what? 4 as my answer. Okay, what is the time complexity? It will be O of n. And what is the space complexity? It will be O of 1. Fine. So it is pretty much optimized than the previous approach. Okay. So By using this O of n time complexity, we also have another approach. So this will be your fourth approach. So this approach is two-pointer approach. Fine. In this name itself, it is pretty much clear. We are going to use two pointers that are pointing to different elements in the two arrays. Fine. How to do this? Initially, I will be taking a pointer here and pointer here. Now, whether these two are same, yes, it is same. So just make this pointer move here. Just make this pointer to move here. Now also it is same. Now again, compare this 6 and this 6, same. Now again, this 8 and this 8, it is same. Again, just go to this 9, here comes 10. Now it is what? It is not same. So I just written this 4. Because these two arrays are sorted, right? So the some element is inserted inside it. Okay, that's the clue. So that we are just going into this two-pointer method. Okay, fine. What is the time complexity? So it will be O of n and space complexity will be O of 1. So this is the time and space complexity analysis for this two-pointer approach. But still, if I tell you we have a still optimized approach, can you believe it? Okay, so if it is still optimized, what will be the time complexity? It is O of log n. We are just going to use a optimized binary search approach here. Okay, in Zoho interviews, they mainly ask us to optimize our code, right? But for this question, whether you can solve this using O of log n, whether it strikes out in your mind. Okay, so if it is not, just continue this video. Okay, fine. So the optimized binary search approach. Okay, so let's get started. Let me just copy paste it. Okay, fine. Now, how to find the midpoint? Okay, so midpoint formula is low pointer plus high minus low divided by 2. So this is the midpoint formula. Okay, I will tell you why we are saying this midpoint formula. Initially, I will be taking my low pointer here and high pointer here in the array 2, not in array 1. Okay, now what is the mid here? The mid will be 0 plus 5 minus 0 divided by 2, which is equal to 2. So come to this 2. So this is my mid. Fine. Now with the same index, just go here also. So here also this 2. Okay. Now I'm going to check whether this 6 and the 6 are same. Yes, it is same. Then it means the before elements of this 2 midpoint will be also same. How? Because they two are sorted and one element is inserted. If that one element is inserted, then these two elements will be different, right? If an element is inserted at this point, okay, then the 6 will be moved one step ahead. Then the two elements will be not same. So at this point, I can say every left elements will be same. So initially, I will be taking my answer as the last index, the 6. Okay, fine. Now I don't want to check anything or modify my answer, just to move to the right side. Okay, if I move to the right side, just make this low pointer to move mid plus 1. Okay, fine. Now what is a mid? Mid will be 3 plus, what is a high? It will be 5 minus 3 divided by 2. So which is equal to 4. So 4 is the midpoint. So this is the mid. Okay, same 4 we want to compare there also. So it is what? This 9. Okay. Now check whether this 9 and this 10 are same. No, it is not same. Which means I can say the 9, this element might be my required answer. It is not sure, but might be. Okay. So I will be making my answer as 4. Okay. Fine. Now just to remember, if two elements are not same, whether going to the right side will get the answer, because going to the right side elements also not same. Okay, just make sure that whenever we insert an element, from that element all the indices that are compared to the both array will be not same, right? See here, from this 9 only, every elements at this indices are differing. This 10 came to 5, whereas here is 4. This 12 come to 6, whereas here is 5. Can you understand this? So here the question is about just a twist. I want to tell you this to make you clear. So we want to check where the smallest index where the array elements are differing. Now can you understand this? Okay. So it is not a purpose to go to the right side. So we want to go to the left side. So make this high pointer to move mid minus 1. Mid to minus 1. Now what is a mid? Mid will be this 3. Okay. So third index is 8. Okay. Now here also third index is 8. So these two are same. If the two are same, just don't do anything in my answer. Okay. And move to the right side. Right side, because left side elements will be same only. Okay, if I move to the right side, I will make my left pointer to mid plus 1. Now low pointer is higher than the high pointer, which means they two are overlapped. If they two are overlapped, just stop here and return the answer. Okay, what is the time complexity? It will be O of log n, because we are using a binary search approach. And what is space complexity? It will be O of 1. So this is the best approach for this problem. Fine. Let us see the program so that it will be more clear. So I am preferring the Java for Zoho. Fine. So this is the function to just search in a binary search approach. Whereas the brute force approach is not given in this solution, because brute force approach is quite simple, right? So I am going with the binary search approach for the just a better approach. Okay, that n log n time complexity approach. So I'm just writing a binary search code here. Okay, to find whether the target is in that array or not. Okay, and here comes the approach. So let me just take this comment. Okay, now I'm just traversing each and every element in my array 1 and checking whether that element is not present in that array 2 by using the binary search approach. If you want to make sure what is this code of this binary search approach, just go and watch my YouTube video. I will give the link in the description for the binary search approach. Okay, fine. Now let me submit it. Yes, it is submitted successfully. Now let us go to the somewhat better approach. So somewhat better approach is the bit manipulation approach. So let me take the comment, and also that another approach, the two-pointer approach. You can try by yourself. If you cannot write the code for that two-pointer approach, just comment below. I will make a separate video, or I will post the code in my comment. Okay, fine. Now int unique is equal to 0 initially. For I'm just iterating in the array 1 and just taking the XOR operation for the all elements in that array 1. Now similarly for the array 2 also. Now at last I'm just going to search in the array 1 that whether the unique element is present and what is the index of it, and I will return that index. Fine. So let me submit it. Yes, it is submitted successfully. Now let us move on to the best approach, the optimized approach, log n approach. Okay, so it is a binary search efficient approach. So initially I will be taking the low pointer as 0 and high pointer as the array 2 dot length minus 1. It is not array 1. Listen this carefully. Array 2. Okay. Fine. Now answer will be array 1 dot length minus 1. The last index of the array 1. Fine. Now while low pointer is less than or equal to high pointer, what should I do? I should first get the midpoint value. Then I want to check whether the midpoint of two arrays is same or not. If it is same, then I can ensure that the leftmost elements will be also same. So I will be moving to the right side, which means low is equal to mid plus 1. If not, it might be the midpoint might be my answer, and also high pointer will be mid minus 1, which means I am moving towards the left side. Okay, for the better answer. In our drawing explanation, we just took 1 as our answer, and it is the better answer, right? But in real time scenarios, we will be taking one answer, and whenever I am moving to the left side, there might be some other better answer. Okay, fine. Now at last I am just returning the answer. Let me submit it. Yes, it is submitted successfully. If you really like this video, just like this video and subscribe to my channel. Just go and watch my entire playlist where you can get a wholesome idea on Zoho interview questions. Thank you.